Okay, for this circuit, we are to determine the voltage gain, the current gain, and the power gain. There are also a few givens. The input voltage is 50 microvolts. The source resistance is 75 ohms. And the load resistance is 18 kilo ohms. Okay, for this circuit, we have a two-stage amplifier. So we first need to determine the voltage gain seen from this point, okay, and then the voltage gain from seen at this point. Okay, so let's take a look at the voltage gain first here. So the voltage gain at that point is given by whatever the AC voltage sees, whatever resistance the AC voltage sees here. And it sees actually 4, R3, R5, R6, and the input base resistance, which you can find here. So and then you divide everything by RE prime. So that's R3 parallel to R5 parallel to R6 and parallel to the input base resistance of circuit 2. Okay, and divide everything by RE prime. Okay, RE prime 1. Now at this point, okay, the voltage gain is given by whatever the AC signal sees here. Since we have a load of 18 kilo ohms here, okay, so 18 kilo ohms, it sees this and this load as parallel equivalent. So we have RC equal to R7 parallel to RL, okay, divided by RE2 prime. Okay, now we note that the resistances here, the voltage divider resistances here is the same as the voltage divider resistance here. The emitter resistance is also the same here, and the collector resistance is the same here, which this implies that RE1 prime is equal to RE2 prime, so we just need to solve for just one RE prime. Okay, and for that we need IE, okay, the DC emitter resistance. So let's begin with that. So the Thevenin voltage is obtained from this equation, R2 over R1 plus R2 times VCC equals 8.2 kilo ohms divided by 33 kilo ohms plus 8.2 kilo ohms times VCC of 15 volts. So VTH is 2.99 volts. RTH is R1 R2 over R1 plus R2. Okay, this is then 33 kilo ohms times 8.2 kilo ohms divided by 33 kilo ohms plus 8.2 kilo ohms, which is equal to 6.57 kilo ohms. Okay, from here we are able to solve for IE, and IE is equal to V, the Thevenin voltage, minus the base emitter voltage divided by RE, okay, plus the Thevenin resistance divided by beta DC. Beta DC is given here. So VTH we know to be 2.99 volts minus VBE, which is 0.7 volts. RE is 1 kilo ohm plus RTH, which is 6.57 kilo ohms divided by beta DC of 175. This gives us an IE of 2.3 milliamperes. Okay, and now that we know RE, we can solve for RE prime. And RE prime is 25 millivolts divided by 2.3 milliamperes, which is equal to 10.9 ohms. Okay, so now that we know RE prime, the next step is to determine the input base voltage at a point 2 or at circuit 2, and also the effective collector resistance at Q2. Okay, so we now solve for the input base resistance. Now the input base resistance in the second stage is beta AC times RE prime. And we know beta AC to be 175, and we just computed RE prime, which means that the input base resistance is 1.91 kilo ohms. So now that we know this, AV1 is just 3.3 kilo ohms, parallel to 33 kilo ohms, parallel to 8.2 kilo ohms, and parallel to 1.91 kilo ohms, divided by RE prime, which is 10.9 ohms. This gives us the voltage gain for the stage 1 to be 94. For stage 2, the voltage gain is 3.3 kilo ohms, parallel to 18 kilo ohms, divided by 10.9 ohms. And this gives us 256 gain for the second stage. Now to solve for the overall gain, we also need to solve for the attenuation. So let's do that. And the attenuation is given by the input total resistance divided by the source resistance plus the input total resistance. Okay, and let's solve for the input total resistance first. Okay, this gives us 33 kilo ohms parallel to 8.2 kilo ohms and parallel to 1.91 kilo ohms divided by, yeah, that's it. Okay, so the result is 1.48 kilo ohms. So that this becomes 1.48 kilo ohms divided by 75 ohms plus 1.48 kilo ohms, resulting to 0.95. And thus the overall voltage gain is 0.95 times 256 times 94, which gives us 22,905. Now the output voltage we can compute from the overall voltage gain multiplied by the input voltage. So this is 22,905 times 50 microvolts, and this gives us 1.15 volts as the output voltage. Okay, note that even though the input voltage is 50 microvolts, an amplifier amplifies everything that it sees at the input, including noise. Okay, so if the noise voltage is comparable to 50 microvolts, then it's going to amplify that as well. Okay, whatever the amplifier sees at the input, it will amplify all of it. Okay, now if we convert this voltage gain to dB, this gives us 87 dB. Okay, now what about the current gain? Okay, for the current gain, okay, at the first stage, we have current gain. We have IC1, which is the current at the emitter, okay, divided by the source current. Okay, the current at the emitter is the voltage, no, not the emitter, the collector. The voltage at the collector divided by the collector resistance. Note that this is small c, so this is the effective collector resistance. And the source current is just the source voltage divided by the source resistance. Now VC1 divided by Vs, okay, is just the gain from the source to the end output of the first stage. So this is 0.95 times 94. Okay, so we already know that. Now this becomes RS over RC1, and RC1, okay, as we already know, is 3.3 kilo ohms parallel to 33 kilo ohms parallel to 8.2 kilo ohms parallel to 1.91 kilo ohms. We already solved this before, and we've already analyzed why this is the case, or why this is the equivalent resistance for RC1. The source resistance is given, it's 75 ohms. Okay, now let's solve for the current gain in stage 2. This is equal to the current, the collector current at stage 2 divided by the base current at stage 2. Okay, so the current, the collector current at stage 2 is just collector voltage divided by the collector resistance. Again, this is the effective collector resistance. Okay, so V, the base voltage, base current is just the base voltage divided by the input total voltage, whatever it sees at the input. Okay, so if you write this, VC2, VB2 times R in total divided by RC, so we should write RC2 here, RC2. Okay, now this is nothing but our gain in the stage 2 amplifier. And the gain in the stage 2 is 256. R in total, okay, is what the second stage amplifier sees at its input. So it sees the okay, so it sees this, okay, this, and also the input base resistance. Okay. Okay, so that means that it's equal to 3.3 kilo ohms parallel to 33 kilo ohms parallel to 8.2 kilo ohms parallel to 1.91 kilo ohms. And RC2 is just the collector resistance seen at the second stage of the amplifier. So that's, let me just verify quickly. R7, which is 3.3 kilo ohms, parallel to 18 kilo ohms. Okay, so R7 parallel to the load resistance. So that's 3.3 kilo ohms parallel to 18 kilo ohms. Okay, now if we rewrite everything, the overall current gain is just VC1 over Vs times VC2 over VB2, okay, times Rs over RC1 times R in total over RC2. Now this is the same with this, so it cancels out. This is just the overall voltage gain AV, which is 22,905. And this is 75 ohms, and we already know what this is. So if we plug in the known values, we get AI equals 616, okay, which is equivalent to about 56 dB. Okay, so that's the current gain. For the power gain, this gives us the overall voltage gain times the overall current gain, which is 22,105 times 616, or 1.4 times 10 to the 7, or about 143 dB. Okay.